Hey everyone. First up, we have a short video that is just on the basics of confidence intervals and the idea of confidence intervals. So, with confidence intervals, we have something called a point estimator. A point estimator is just the statistic that we calculated previously. For instance, if we wanted to find the population mean mu, the point estimator was the sample mean x bar. If we wanted to estimate the population proportion p, we would use the sample proportion p hat. In general, if we want to estimate any population parameter, theta, you see a theta hat down here. This is the Greek letter theta, but with a hat over it. We use the sample statistic, or we call the sample statistic theta hat. Point estimators are easy to find. I mean, we've calculated them in the past, but they have a few drawbacks. First, if we have a large sample size, then the estimate is better. But with a point estimator, you don't know what the sample size is, and you don't know how accurate the estimate is. Both of these problems are solved with a confidence interval. A confidence interval is where you have an interval surrounding your parameter, and this interval has a chance of being a true statement. In general, a confidence interval looks like this. It looks like an interval theta hat plus or minus capital E, where theta hat is the point estimator and E is a margin of error term that's added and subtracted from this point estimator, thus creating an interval. And confidence intervals have some level of confidence, such as 90%, 95%, or 99%. Those are going to be the most common probabilities that are used for confidence intervals. For example, if you have a 95% confidence interval that p is between 0.65 and 0.73, you would say there is a 95% chance that the interval 0.65 to 0.73 contains the true population proportion. This means that if you have 100 intervals, 95 of them will contain the true proportion and 5 will not. The wrong interpretation would be that there is a 95% chance that the true value of p will fall between 0.65 and 0.73. The reason that interpretation is wrong is that the true value is fixed out there somewhere. You're just trying to capture it with the interval. So this is the chance that your interval captures the true value, not the chance that the true value falls into the interval. We often refer to the confidence level as 1 minus alpha, where alpha is the complement of our confidence level. So if alpha is 0.10, then we'd be looking at a 90% confidence interval, because 1 minus 0.10 is 0.90. And there's a trade-off between the width of a confidence interval and the confidence level. You can be really confident about your answer, but your answer will not be very precise. Or you can have a precise answer with a small margin of error, but not be very confident about your answer. So the idea here is that if you make your confidence interval really, 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 really wide, then you are increasing the chance that you are capturing the true value in your confidence interval. But at that point, you have this huge margin of error, and it might be essentially pointless. Like if I were to say that the average height of a human is between 1 foot and 100 feet, right? That a 99% confidence interval for the average height of a human is 1 foot tall to 100 feet tall. I can be really confident that the average height of a human falls between 1 and 100 feet. But that doesn't tell me much about exactly where in there the average height of a human would be. And sample size also has an effect on confidence intervals. The larger a sample size is, this makes the sample, or like rather a larger sample size from a representative sample makes the width of the interval narrower because large samples are closer to the true population. So our point estimate should be pretty close to the true value. So you see here, going from n equals 30 to n equals 100 to n equals 1000, that the width of the confidence interval decreases each time. And in 8.2, we're going to be talking about one sample intervals for proportions.